Assalamualaikum warahmatullahi wabarakatuh. My name is ASHRAF bin AZIZ, and today I would like to present to you about my project, which is case study on material selection of natural fiber reinforced polymer composite POTHOLE based on manufacturing process requirement. My supervisor is Puan Nur Aimanah Hanis binti Hasim, and my co-supervisor is Dr. Masra binti Muhammad Taha. My presentation is divided into 4 topics, which are introduction, literature review, methodology, and expected result. Let me give some brief first before proceed to my main objective. Road has been important part in our life, and over time, they will reach their limit and start to damage. This is due to increasing heavy traffic load and change of weather. Well, pothole repair do not last long because of its bad quality. Thus, some studies said that natural fiber reinforced polymer composite can improve their performance. But there are a lot of natural fiber and polymer that can be used in asphalt mixture. So, the problem that we are facing is to get the best natural fibers and polymers to be used in asphalt mixture. Then, the suggestion that we made is to study the material criterion, and in my scope, thermal and chemical properties are being studied. And the solution is we will give rank to the material selection by using Park decision matrix. So, my main objectives are to study the material selection criteria for natural fiber reinforced polymer composite potholes based on the manufacturing process. And my second objective is to rank and select the most suitable natural fiber and polymer by using Park decision matrix. My scope objective is to study the material criterion and proceed to give the ranking score based on their thermal properties and chemical properties. And lastly, to choose the best natural fibers and polymers based on their ranking score. From my literature review, the polymer is large molecule that consists of repeating subunit known as monomer, and natural fiber is thin thread that extracted from animal and plant. And combining natural fiber with polymers will form natural fiber reinforced polymer composite. There are a lot of advantages of natural fiber reinforced polymer composite, such as durable, high strength, lightweight, good insulator, and dimensionally stable. From Muhammad et al. 2015, they state that natural fiber reinforced polymer composite has been applied in a lot of sectors like construction and building, road pavement, automotive, and sports. So the literature review path is pothole. Pothole is bowl-shaped damage that form on road pavement, quote by Sharma and Kanongo 2015, and the causes is because of heavy traffic loads and weather change. Pothole repair is very temporary because of the quality of asphalt mixture. And Fu et al. 2017 said that the quality of the asphalt mixture can be increased by using natural fiber reinforced polymer composite. So the material criteria is to study based on manufacturing process requirement and to give the ranking score for the best natural fiber and polymers based on part decision matrix. In the next slide, I attach my flowchart, and their steps are the process of collecting the data for material that being shortlisted, then to ranking to give the ranking score based on thermal and chemical properties, and finally decision will be made to select the best material. So 4 types of polymer and 4 types of natural fiber has been shortlisted, which is propylene, polystyrene, low density polyethylene, high density polyethylene, and for natural fiber, coconut fiber, hemp fiber, jute fiber, and sisal fiber will be studied. The manufacturing process temperature for asphalt mixture are range from 120 degrees Celsius to 170 degrees Celsius, which they will cause heat and oxidation. So, thermal properties and chemical properties for natural fiber and polymer need to be considered. When comparing the polymers, PP, which is polypropylene melting point, is 160 degree to 170 degree, and HDPE melting point, which is high density polyethylene melting point, is range from 120 to 140, and they are in the range of manufacturing process temperature of asphalt mixture. This indicate that PP and HDPE will be fully melted during the process of asphalt mixture. For PS, which is polystyrene, the melting point range from 240 degrees Celsius to 270 degrees Celsius. And PS is not suitable to be used in asphalt mixture process because they will not reach their melting point. And for the glass transition indicate that how easy the polymer to turn from solid state to rubbery state material. So here PS has the highest glass transition temperature, which are from 100 degrees Celsius to 135 degrees Celsius, followed by LDPE from N temperature to 120 temperature, and HDPE from N temperature to 80 degree Celsius, and indicate the unknown number. And lastly, PP has the lowest glass transition temperature, which is from 0.9 degrees Celsius until 1.5 degrees Celsius. Besides that, the polymers are required to stay in solid state so that it can stay hard and strong when the patching and repairing pothole is done. Atmospheric temperature in Malaysia are in range from 25 degrees Celsius until 38 or 40 degrees Celsius. So PP is not suitable as it will always stay in rubbery form. So for the ranking score for the polymers are given based on their thermal properties. Manufacturing process compatibility mean that which polymer are the most suitable to mix in the asphalt mixture based on the manufacturing process temperature. The solid state mean which polymer are able to stay in solid state after the process of pothole patching is done, and then the score is given. So here we are able to indicate that HDPE has the highest total score. For the natural fiber, we are going to discuss about thermal and chemical properties. Coconut fiber has the highest lignin content, which is 45% when compared with jute, hemp, and sisal, which are 12 to 13, 3.7% to 5.0%, and 5 to 12% respectively. Highest lignin content shows that the coconut fiber is the strongest and most strand fiber among the other fiber. And then for the cellulose content, the fiber that have the high cellulose content are very hydrophilic, which means that they will absorb more moisture and it can negatively affect the properties of natural fibers. Sisal fibers has the highest range of cellulose content, which range from 60 to 67% to 78%, compared to hemp and jute, which are 70% to 74% and 61% to 71% respectively. And coconut fibers has the lowest cellulose content, range from 32% and 43%, which indicate that it has the lowest moisture absorption, so it is the most waterproof fibers. For their decomposition temperature, it indicates that the temperature which the fiber start to lose the properties in strength and stiffness due to high temperature. However, decomposition temperature for all of them are higher than the manufacturing process temperature of asphalt mixture, so they are suitable to use in asphalt mixture process. And then the Park decision matrix for natural fiber are given. Based on the score, coconut fiber has the highest chemical strength composition as it has the highest lignin content, and coconut fiber has the highest water resistance due to low cellulose content and high water resistance because of its waterproof. Lastly, the ranking score based on the Park decision matrix for both polymers and natural fiber can be concluded. It indicates here that HDPE and coconut fibers has the highest rank score, which means that they are the most suitable candidate to be used in the manufacturing process of asphalt mixture. I guess that's all from me. I hope you enjoy and understand well my presentation on this project. Thank you.